So this problem says, let -3, -4 be a point on the terminal side of theta. Find the exact values of the 6 trigonometric functions. So whenever they give you something where you have a point, I always like to draw out my x and y axes, and you're going to draw out the triangle from there. So remember, your triangle, you always want your theta to be at your origin. So we're going to go -3, let me use a different color. We're going to go -3 to the x side, we're going to go -4y, and then we're going to connect this. My pre-cal teacher in high school always told us to visualize it like a bow tie. So whenever you're drawing out these triangles, make sure you've got your right angle in, you've got your theta in here, and you want your right angles on the outside along the x-axis. So now we've got our triangle. We have to solve for our hypotenuse here. So we're going to use handy-dandy Pythagorean theorem. So we've got 3 squared plus 4 squared. I'm not paying attention to the negatives. 1, because they're going to go away because we're squared. 2, because the hypotenuse, no matter what quadrant you're in, the hypotenuse is always going to be positive. That's really important, because the hypotenuse is not a measure of which direction you're going. It's just a strict measure of distance. It's a solid amount. You cannot travel negative distance. So just keep that in mind. So we're going to have 9 plus 16, which is 25, so that means our hypotenuse is 5. So now we just have to plug in these values for our trig ratios, and remember our best friend, SOHCAHTOA, that's a T for tangent. So sine is opposite over hypotenuse, so opposite is -4/5. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent, so we're going to have 4/3 because those negatives will cancel out. Cosecant is the inverse of sine, so we're going to have -5/4 here. Secant, we're going to have -5/3 because that's the inverse of cosine. And cotangent is going to be 3/4. And that's all she wrote.